And again, welcome to today's class. And at Kenyatta University, and this is going to be ninth class, and we're going to talk about something very small yet very important called address resolution. And address resolution is actually a protocol called ARP. It's actually a protocol called ARP, and we are going to see why is it important, to have ARP. Now, so this is a very brief one. After this, then we'll talk about, we'll go back to the command line, and we're going to review the commands that we had learned before, So we'll explain how ARP, which is the protocol in IPv4, and it has a different name in IP version 6, because in IP version 6, we call it ND or NDP, where ND means neighbor discovery, ND means neighbor discovery, and NDP means neighbor discovery protocol, And basically, this is a protocol that works with the MAC addresses and IP addresses. Remember that IP address, we talked about the IP address in the network layer and the MAC address on the data link layer, all right? So what is the relationship between normally the MAC address, the IP, and the ARP protocol? Some people call it the ARP, so on and so forth. So now, it's important to note that every packet must have a source and the destination IP address, and the IP address is also called a logical address, a layer 3 logical address. Of course, we talked about MAC address, and the MAC address is also called the physical address. And we say the major function of the physical address or the MAC address is for communications from one end device, NIC, to another NIC of another device on the same network. While IP addresses are used to send packets from one source device to another destination device. So layer 2 addresses or MAC addresses, they used to deliver frames within the same network from one NIC or from one end device to another end device on the same network. But the layer 3 address is used to deliver packets from one device to another device on different networks. And it's important to note that since ARP is only used within the same network, whenever ARP wants to send something to a destination networks, it only needs to send it to the default gateway, which is always on the same network. What do I mean? Looking at the diagram that we have here, looking at this diagram that we have here, it is important to note that if I can just zoom this in a little bit, we learned that all of this is one network, okay? From the router interface here to the switch to the PC, whereby the IP address of the router here, this is what is called the default gateway of the whole of this network. This is a local area network. So this IP address on the router interface is our default gateway. And why do we call it a default gateway? We say that it's called a default gateway simply because it is our only way out to other networks, okay? It's our only way when you want to access or reach or send a message to another network. So the router is called the default gateway, but the IP address of the interface of the router here is called the default gateway address, okay? Now, about ARP, is a very simple protocol. And the first thing you need to note is that before any PC sends a message to any other device in the network, it must know two things about that device. If that device is in the same network as that device, it needs to know, one, the IP address, and two, the MAC address. Now, being that they're on the same network, the IP address is always known because they share the same network address and the same subnet mask. So the IP address is always known. What is not always known is the MAC address. And so ARP, it's used to resolve the IP address to MAC address mapping, and of course for maintaining a table called the ARP table, which is only found in a PC or a router, not a switch. And so at this point in time, I want to just take you through this, and I want you to see what happened during ARP or ARP. Okay. So so the first thing that I want you guys to see is, look at this. Look at what happens here. So we do have PCH1, and PCH1 is saying that I must send out an ARP request to learn the MAC address of a host device whose IP is 192.168.1.7. Clearly, that is PCH4. PCH4 is the destination of a packet that PCH1 needs to send. So what happens is that PCH1 is going to pose the packet it needs to send to H4 because it does not know the MAC address of H4, but it knows the IP. So because it does not know the MAC address of PCH4, what's going to happen is that H1 is going to send an ARP request, which is a broadcast message. So each of the three PCs, H2, H3, and H4, each of them is actually going to receive the ARP request, but only the owner of the IP, which is 1.7 here, is going to respond and send an ARP reply. So let's see. So H1 sends it, it goes as a broadcast. PCH2 says this is not me, or this isn't me. PCH3 says this isn't me. How do they know it is not theirs? Because the IP does not match that which they have. But PCH4 says this is me. I'm gonna send back my MAC address. I will now send back my MAC address, and let's see that PCH4 sending back an ARP reply. All right. So you see that now PC can now forward the information it wanted to send to PCH4. Okay. Only after sending an ARP request to request for the owner of that IP to respond back with its own MAC address. Okay. Once that specific target PC has responded back with its own MAC address, then PCH1 can now forward the message it intended to forward to PCH4. And that is how ARP or ARP works, every PC. Now, how do you know this? How to know this is because sometimes, and let me just display for you guys the ARP table here of my PC. So I'm gonna open my command prompt here, and I'll type there ARP space -A. All right. So I can zoom in that. So when I type ARP space -A, it's gonna give you my ARP table. And ARP table is going to constitute a column of IP addresses here and a column of MAC addresses here. Like I mentioned before, every time you see a MAC address of FFFFF, you know that is a broadcast MAC address, and the IP address must also be broadcast. Now, one of the IP addresses that you must always see here is the IP address here of my default gateway, and you can see it here. And this is the MAC address of my router interface. Okay. Now, since I am in the same network, I can just demonstrate something here for you guys to see. What I'm gonna do is that I want to check the IP address of my phone. So the IP address of my mobile phone, which is in the same network, is 192.168.0.106. Clearly you can't see it there, 192.168.0.106. 192.168.0.106. So please follow this with me. I cannot see 192.168.0.106 here, but when I try to send some packets to my phone from my computer by pinging that particular IP, then trust me, it's gonna appear on the ARP table here. Right now, obviously you can see 192.168.0.106 is not here. We have the closest is 103. So I'm gonna go ahead and ping my mobile phone. So ping 192.168.0.106. All right. So I'm gonna ping it, and my phone is sending for me replies because it is reachable. And now when I do the same command, ARP space A, and I press enter, and now I can zoom this in, and look at that. Look at that. My IP address is now here of my mobile phone, and its MAC address is now here. And it's obtained, of course, dynamically. So it is important for you. I'm just trying to justify why for my PC, my laptop, to send a message or some packets to my phone, it must know two things. It must know the IP address, and it must know the MAC address. If it doesn't, the first thing it will do is to send an ARP request. That is actually what it did, but it happened so fast, and my phone was able to send back its ARP reply, and that's how the ICMP packets of the ping were able to be sent to my computer. And my computer now is storing the MAC address and IP of my phone. All right. So every device must do that. That's why the MAC address is very important, the physical address for any device. It is used by the switch on the MAC address table. It's also used by the PC on the ARP table. I need to mention this. Only the PC and the routers, or end devices and the routers, have ARP table. The switch does not have an ARP table. The switch just has a MAC address table. All right. All right. So I hope that's clearer enough there. All right. Of course, those who want to confirm that the previous, of course, the previous was not having my phone here. You can see 106 is not here. All right. All right. That's okay for sure. Now, yeah, so let me just go back to my slides. Yeah, so that's an overview of the ARP table. Of course, in a router, if you want to view the ARP table or the ARP table, use this command, show IP ARP. But in a PC, you say ARP space -A. If you want to delete the ARP table or reset it, you just do ARP space -D to delete, you know, that particular table, to delete the table there. All right. Now, because of, you know, ARP can have some issues normally. And so the first issue is what we call the ARP broadcasting, you know, or ARP broadcasting, and ARP spoofing is the other one. These are basically attacks that are used to overwhelm. The broadcasting overwhelms. For example, let me give you an example of normally what will happen here. Normally, any diagram you see, and this is drawn, this simulates, of course, a hacker or a bad guy, all right, or a bad lady for that matter. And the thing is, let's say that this honest PC here, PCA, at an IP of 192.168.1.110, wants to send an ARP request to learn the MAC address of the router, which is at 192.168.1.1. So it's going to send that message, ARP request, to the switch. The switch is going to broadcast it PCB to the router itself, and even the hacker himself. So what happens is that The hacker, even before the router responds, is going to send an ARP reply back to PCA, pretending to be R1, which is the default gateway. And so PCA is going to store that information in its ARP table. It's going to store the IP of R1 and the MAC address of the hacker's laptop there or computer. And so PCA is going to believe that every time that it wants to send something to the default gateway, since the default gateway is in the same network, it's going to send it to the hacker's network. And the hacker can take advantage of the network, So this is, a very good example of spoofing and broadcasting, be able to taking advantage or compromising the ARP table of any other device. So like I mentioned, guys, ARP is used in IP version 4. ARP is used in IP version 4. Just a minute, guys. So I had mentioned, guys, to you about ARP, which is for IPv4. IPv6 has a similar thing, only that the name is different. The name is different. The name is called ND or NDP. And ND means neighbor discovery or neighbor discovery protocol for DP. All right. Now, IPv6 also does what is called address resolution. Okay. Of course, it can do router discovery and redirection of services. So to do address resolution, IPv6 uses 4 messages. Okay. There are 4 messages. 2 of them are used to do address resolution, and 2 of them are used for router discovery. So the ones that can be similar to ARP request and ARP reply. ARP request is similar to what is called the neighbor solicitation message. Okay, NS. Neighbor solicitation message is the equivalent of an ARP request. Neighbor advertisement. Neighbor advertisement is the equivalent of ARP reply. It's equivalent for ARP reply. Okay, so address resolution is done by the NS and NA. From the neighbor solicitation, I don't want you to pick them as very complex terms. Think about the word to solicit. To solicit basically means to seek for or to search for. If I say I'm going to solicit for funds to build an orphanage, okay? I'm going to look for funds. I'm going to seek for funds from people or philanthropists to use it to, building an orphanage. So NS and NA, neighbor advertisements. Of course, we also have RAs and RA, and we shall talk about this much in detail later on in the next chapter, chapter 12. All right? Yeah, chapter 12, I think so. Yes. So don't worry about those 4 messages. Now, like I mentioned, like I mentioned here, I just want to demonstrate this a little bit here. Correct, this one. So let's say this PC1 wants to send a message to PC2, but PC1 does not know the MAC address of PC2. Okay, but it knows the IP definitely because they are on the same IPv6 network here. So what PC1 is going to do is that PC1 is going to send an ICMP neighbor solicitation message saying, hey, whoever has an address 2001:db8:a card:1:1 please send me your MAC address. That's the neighbor solicitation message. PC2 is going to receive it and respond back to PC1 saying, hi, PC with address 2001 DP8 ACAD:1:10, that is PC10. I am :11 here, and my MAC address is actually here. So you realize it's basically doing the same thing, but using the neighbor solicitation message and neighbor advertisement message, just like ARP request and ARP reply. So basically, very, very similar. Basically, very, very similar. So that was very short. That was ARP, and now I want us to change gears a little bit and